Okay, so we'll continue with our complex numbers. So, as I told you, complex numbers can be written in the form z is equal to x plus iy. And when we learn complex numbers, we have to be sure about two more things. One is called the complex conjugate. And the complex conjugate means replacing I with minus I. That is, you just replace I wherever it is with minus I. For example, the complex conjugate, which I'm going to denote by Z bar. Okay, in some books they might use Z star also. So expect Z star or Z bar is simply x minus iy. Okay, so if you have a complex number 3 plus 7i, then what will be the complex conjugate? Yeah, you're right. 3 minus 7i. So the logic is replace I with minus I. Okay, and if you have something like e to the power I theta, okay, it's a complex number. So what might be the complex conjugate? Okay, as I told you before, you just put minus I instead of I. Okay, the next thing the next thing is modulus. Modulus means the distance from the origin. So in real numbers, things were very easy. This is the real number system. Of course, I'll put infinity over here, and I'll write minus infinity on this side, and we have the origin in the middle. Okay, so what do you mean by modulus of 7? Modulus 7 means the distance of the point 7 from the origin. So the answer will be 7 units. Okay, so what about modulus of minus 3? As I told you before, modulus of minus 3 means distance of minus 3 from the origin. Since distance is positive, I'm sure you're going to write the answer as 3. Okay, now let's move on to complex numbers. So we have a complex number, and I'm going for the general format x plus iy. And if you want to plot a complex number, we just use the coordinate system, the Cartesian coordinate system, x comma y. So if you have the complex number 3 plus 4i, then what we do is we just plot the point 3 comma 4. Is that clear? Okay, so let's have a small graph. Okay, so I'll go for z is equal to x plus iy, and the coordinate x comma y. So we have a graph over here. Okay, I'm not that good in drawing, so you can just imagine this is the x-axis and the y-axis, and let's imagine, or let's just call this to be x, and let this height be y. I think you remember from your high school classes how to plot points in a graph. So this is basically x comma y, or the complex number x plus iy. Okay, my question is, what is the distance of this complex number from the origin? So modulus of z, as I told you before, implies or means the distance of the complex number from the origin. Okay, that's very simple. This is x and this is y, and I want you to make a guess. Yeah, you're right, because if we use Pythagoras theorem, it will be x square plus y square inside a square root. So the modulus of a complex number is, there is no negative here, so the modulus of a complex number is nothing but root under x square plus y square. I think I had to erase that part, otherwise there will be confusion. So I'll write once more. So modulus of a complex number is nothing but root under x square plus y square. Okay, now the next thing is equality of complex numbers. Just imagine there are two complex numbers, x plus iy and let's say a plus ib, and the complex numbers will be equal provided the real parts. Do you still remember real part? So what's the real part in the left hand side? Yeah, that's x. And what's the real part in the right hand side? Of course a. So two complex numbers are equal, then the real part must be equal and the imaginary parts must be equal. So that's the equality of complex numbers. Okay, now let's move on to addition of complex numbers. That's really simple. Suppose you have a complex number a plus ib and another complex number c plus id. So if you're going for the sum, it's very easy. You just add the real parts and then you go for the addition of the imaginary parts. Same with subtraction, so I'm not going to write that here. Okay, now the next one is very important, that is powers of I. Okay, so I hope you still remember what happened to root under minus 1. Okay, so root under minus 1 is I. Okay, so what will be I square? Yeah, of course, when you square on both sides, you're going to get minus 1. So I cube will be, I cube is I to the power 2 plus 1, and that will be I to the power 2 into I to the power 1, that is I of course, and that becomes minus I. Okay, and finally I to the power 4, and that is I square into I square. If you use the same logic, you're going to get I square into I square, and I square is, what's the value of I square? Okay, so you end up with minus 1 into minus 1, and that gives you 1. Okay, now I want you to do one thing. Take a sheet of paper and pen and note these 4 things. Root under minus 1 is I square is minus 1, I cube is minus I, and I power 4 is 1. Okay, you can pause the video for a second and get a paper and pen and note the 4 things. Okay, so I hope you have the pen and paper with you. Okay, now I'll give you an identity, that is a to the power m plus n is a power m into a power n. Okay, so what might be I to the power 7? I think you just wrote I power 4 is equal to 1. So I'm going to write this in terms of I to the power 4. So I'm going to get I to the power 4 plus 3, and that will be I cube. Am I right? Are you confused? Okay, I'll do one thing. I'll just make it I to the power 4 into I to the power 3. I just applied this laws of indices. But what is I to the power 4? What is I to the power 4? I think you already noted it. So you're going to get 1 into I cube. And now take a look at the list. I'm sure you have the value for I cube, and that is minus I. So what's the answer? Minus I. Okay, now we go for the trick. Suppose you want I to the power, let's say 23. The trick is, give me any number which is less than 23 and a multiple of 4. The logic is very simple. What is I to the power 4? Okay, I to the power 4 is 1. And since I to the power 4 is 1, I to the power any multiple of 4 will give you 1. So if you want I to the power 23, the easiest method is to find the number just less than 23 but a multiple of 4. And that number is, okay, so I'll write this as I to the power 20 plus 3. If you want, you can use the same logic. Okay, I'll do it. I'll make it like I to the power 20 and I to the power 3. But this is a multiple of 4, so that becomes 1. And what's the value of I cube? Can you check the list? Or you can check it over here. I cube is minus I. So you're going to get the answer minus I. Once more, suppose you want I to the power 15. Can you give me the number just less than 15 and a multiple of 3, 4? That will be 12. So 12 plus 3. So you end up with I cube again. I think I have to change the example. So you're going to get minus I. Okay, now let's go for I to the power 30. Okay, so can you give me the number which is just less than 30 but a multiple of 4? Okay, that's it. 20, what's the number? Yeah, 28. And then you go for plus 2. So what will be the answer? Now I'm going to reduce the step. That will be I square. I'm not supposed to write this. Can you check the list? What was I to the power 4? It's 1. And what did you write for I to the power 3? I guess you have collected it as minus I. And can you please check what is I square? Yeah, it's minus 1. So you're going to get the answer minus 1. Okay, and I want you to remember this thing. You can remember the numbers 20, 40, 60, 80 to reach the multiple of 4 really fast. For example, if you want to check the multiple of 4 which is very near to 67, you just start with 60 and then add 4. So what's the number? 64. So suppose you want the multiple of 4 which is just less than 95, you just start from the number 80. So 80 plus 4 gives you 84, and then add one more 4, you get 88, and then 92. So the number which is very near to 95 but less than 95 will be 92. Okay, so let's work out one more question. Suppose you want I to the power 93. As I said before, you start with the number 80 and then slowly move on to the number which is less than 93 but a multiple of 4, and that will be 92. Okay, so now you don't have to write this, you have to imagine in your mind that is 93 is 92 plus 1, and you apply the past logic, you're going to get I to the power 1, and that is I. Okay, now what will be I to the power 9, 3, 8, 4, 5, 6, 1, 2, 3, 4? What might be the answer? Okay, we have an interesting result here, the multiples of 4. You might have noticed 25 times 4 is 100. That is, 100 is a multiple of 4. And now the result becomes very interesting. If you look at the multiples of 4 from the beginning, they are like 4, 8, 12, etc. Now, if you look at the multiples just beyond 100, the numbers will be 104, 108, 112, etc. And if you look at the multiples beyond 1000, it will be like 1004, 1008, etc. So what I'm trying to convince you here is, Let it be any large number. You focus on the last two digits and use our previous trick. So let's focus on 34. So can you give me the number which is just less than 34 and a multiple of 4? Yeah, that is 32. So we have 32 plus 2. Okay, applying the previous logic, we're going to get I square, and that will be minus 1. Okay, now for negative powers, you have to be very careful with this one. What might be I to the power minus 13? Can you give me a number less than minus 13 but a multiple of 4? Okay. I think most of you are thinking about the number minus 12. It happens. But remember, a number less than minus 13 and a multiple of 4 will be minus 16. So it's like minus 16 plus 3. So what's the answer? I to the power 3, and as before, the answer is minus I.